Assalamu alaikum warahmatullahi wabarakatuh. Dear students, this is Dr. Ali El-Moursy, and we are in lecture number 19, part 1 for Digital Logic Design course. Today we will present the encoder-decoder circuits. Encoder-decoder circuits. Before we go into the details of those new devices that we are learning in DLD, we need first to represent the concept of coding. The word coding is used extensively in our daily life, and the concepts for encoding and decoding is used in our daily life in many aspects, not only in digital logic design. I need the students to grasp the concept. The most important thing for you is to grasp the concept before going even and learning what's going on and how the circuit is being built. Okay, you have to get the concept of coding in general. What does it mean by coding? When I code something, the word in Arabic means tashfir. Coding, that means you are giving some code for things. What does it mean by coding? Uh, when I have a code for something, that means I convert the entity, the two much entities, each of them I assigned for them some number or letters to identify them. Like what? Like the IDs for our numbers in university. Each student in the university has what we call the student ID. We have the student ID. So we code the entity of the student into a number. By the way, this is used not only for the students, for all the employees. Dr. Ali El-Moursy has an ID number in the university code. The number of the Dr. Ali El-Moursy is ID is 10905. Okay, so through those 10905, 5 digits, through these 5 digits, I can identify different entities. The process of assigning a code to an entity, this process called encoding. The opposite, so when I say that Dr. Ali El-Moursy is one entity, when I give him a code, when I code him into a number, this process is called the encoding. That means giving a code or a number to represent the entity. The opposite operation, which we call the decoding operation. If I give you a number or employee ID or student ID, if you will be able to identify this number belongs to which person, that means you are doing a decoding. So we are dealing with two operations, the encoding operation and the decoding operation. By the way, the concept is used in our daily life in many things. Like what? Like the plate number for your car. Each car has a plate number. So when I give a car a number, definitely the numbers in the car plates more flexible than the numbers of the student IDs or the employee IDs, because it actually accepts both numbers and letters, character letters. Okay, so for instance, if your car is taking maybe AES 1532. This code is for your number, okay? With whatever number of digits that you are using here, okay? So when you give your car, or the authority give your car an ID or a number or a car plate, this process is called encoding. Because right now this number representing the car. So right now, using this code, I can decode it and identify this car belongs to whom, and so on. So this concept is used in our daily life extensively. Agreed? Now let's take another example for the encoding and decoding. Okay, so well, the concept looks to be nice, the concept looks to be useful, but how this affects our digital logic design. And we have a very interesting example that I used always to mention it in the English, in the computer system. Can you still remember chapter 1, the last lecture of chapter 1? We talked about the coding. It's not our first time here to discuss the coding. Okay? If you go back to chapter number 1, the last lecture of chapter number 1, we talked about the ASCII code. Again, coding here. So what's the ASCII code? ASCII code is a method, okay, in order to code each character in the English language, okay, converted into a number. How big is that number? We already discussed it, because actually, if I have a keyboard, I have, let's just show a keyboard here. Here we have a keyboard. Let's take this keyboard. Can you see this keyboard? Okay. So the keyboard has buttons, all the buttons of English language characters, and also special characters like the and sign, the enter sign, all different special characters here. Okay. So how do you imagine that this keyboard works? This keyboard is a group of buttons, and those buttons are simply switches. Switches means they only take one of two values. The switch could be either 0 or 1. If you didn't press any button, so the switch will take the value 0. If you press the button, the switch will take the value 1. Agree? So now, for the keyboard, since I have here, assuming that I have maybe 250 different buttons in the keyboard, okay? Whatever, pick the number, or maybe 180, okay? So what is the purpose of giving an ASCII code for each button of my keyboard? Right now, the ASCII code is doing what? It's not doing that, because actually, as we mentioned in the ASCII code, I have 8 bits. Why 8 bits? Because here I need the capital and small letters, and also I need the special characters. Okay? So all those will representing maybe 200 something. Okay? So that means I need the 8 bits to represent each of those combinations. So for instance, we will give the combination 0, 0, 0, 0, 0, 0, 0, 0, all zeros to letter A. Then combination, the next combination 1, 0, 0, 0, 0, 0, 0, 0 to letter B. And then I'm just giving an example. Okay, this is not actually the ASCII, but this is just an example. 0, 1, 0, 0, 0, 0, 0, 0 for C, and so on. So coding or writing the ASCII code or coding is very helpful in the design of my keyboard. Why? Because right now, as we mentioned, the keyboard is just a group of buttons. Okay? So right now, those buttons, which are switches, do you imagine that in order to deal with the keyboard, I have to get here from that keyboard 100 something or 200 different wires to connect the keyboard to my PC? Do you think that this wire carries 100 and something wires or 200 something wires? No, because once I have here inside the keyboard, I have an encoder that will actually give a code for each of the buttons of the keyboard. That means I translated the letter on the keyboard into only 8 bits. This is actually what is happening here. So here I can have only 8 wires. Those 8 wires are carrying the combinations of ones and zeros getting out of the encoder that is inside this keyboard in order to code the buttons that are pressed for each case. So whenever you press a button, I can identify. So the process is going like that. So here, in order to translate or converting the buttons of the keyboard, each of them is just a wire, okay, into an 8-bit of combinations here, getting out of this keyboard 1, 2, 3, 4, 5, 6, 7, 8. So those wires here will simply give me what? Give me the value of the combination for what is the button pressed here. So accordingly, here I'm using an encoder to code the 256 combination of inputs and converting them into an 8 wires. So if you press the letter A, I will have the all zeros. If you press the letter B, I have 1000 and so on. So I have to have a device to help me to do that. And this device is called what? It's called the encoder. Now I get that code, send it to the PC. Okay, so I have got here 8 wires from the PC. To the PC. 8 wires connected to the PC. Okay, those 8 wires will go through a device called what? Called the decoder. The decoder has the mission to convert the 8 wires to 256 different combinations for the different combinations of that number. Why Dr. Harris keeps saying 256 by 8 and 8 by 256? Because we learned in DLD chapter 1 that if I have 8 bits as the output of the encoder, input for the encoder, those 8 bits will give me 2 to the power a number of bits of combinations. So the number of combinations that I have here are 200 is 2 to the power 8, which means 256 combinations. So this is the relationship, okay, between the inputs and outputs for the encoder and the inputs and outputs for the decoder. Okay, so accordingly, right now, if I have got the combination, okay, here, assume that I have received at the input of the decoder 0, 0, 0, 0, 0, 0, 0, 0. The decoder will tell me that, well, if you have this combination, that means the first output is enabled, which is corresponding to letter A. If I received at the input of the decoder, okay, the combination 1 0 0 0 0 0 0 0. Okay, so this combination is given to B. Okay, so that means the decoder should actually give me a 1 here to indicate that B is pressed, and will give 0 otherwise. If I have the first combination, it should give me 1 here and 0 otherwise. Okay, so the decoder, now I can get the operation of the encoder and decoder. Encoder, when I have one signal from here, it should reflect on all zeros. When I have one here, I should have 1 0 0 0. When I have one on the C, I should get 0 1 0 0, and so on. And the opposite is being performed by the decoder. And the decoder device, by definition, is doing what? Is converting for me the combination that I'm receiving here into identifying the pin that is being pressed. Okay, so if I ever, as a third example, if I ever get 0 1 0 0 0 0 0 0, means the combination that I have received here should be for the third input here, which is number C. So that means here C should be 1, and I have to have zeros otherwise. If the decoder has the mission to enable for me only one output to be 1, and the rest will be zeros. The question here is which one of those will be enabled and the rest will be disabled, will be zeros. Okay, it depends on what? It depends on the combination that has been received at the input. So if I have the first combination 0 0 0 0 0, the first output will be 1 and the rest will be zeros. To translate, to indicate to me which combination received. If I have 1 0 0 0, that means this will be 1, the rest will be zeros. If I have 0 1 0 0, that means 1 here and the rest will be zeros. Okay, let's try the last one for D. If we go sequentially, so the next combination here will be 1 1 0 0 0 0 0 0. So, and this should be for letter D. So that means here the D is number 3. D should give me a 0 0 0 1 at D and 0 otherwise. Okay, so this is the operation of the encoder and the decoder circuits. So the decoder, which we focus on the decoder more than the encoder, because the decoder has more usability in different circuits. So the decoder have a specific number of inputs and has 2 to the power the number of inputs as outputs. We are describing the operation of the decoder. It has n inputs. It has 2 to the power n outputs. Based on the combinations of the pins of the input, one of the output will be 1 and the rest will be zeros. Why is that? To identify which combination entered. So if I have all zeros at the input, the first output will be 1, the rest will be 0. If I have the second combination, layer 1 0 0 0, it means the second will be 1, the rest will be 0. If I have the third combination, 0 1 0 0, that means the third one will be 1 and the rest will be zeros. If I have the fourth one, the fourth combination is 1 1. Okay? 1 1 0 0 0 means the fourth one here, 0 1 2 3, the fourth one will be 1 and the rest will be zeros. Okay, so this demonstrates to you and explain to you how can we use the encoder-decoder circuits, and their advantage is very clear, because right now I actually avoided, for the practical example that we have discussed, I avoided here in my keyboard, okay, to have a huge number of wires coming out. Okay, I converted the too many variables into hello hello